Assalamu alaikum. Good morning, everyone. Can you hear me? Okay, very good. All right. What was your question, Judy? ايش اللي قبل العيد وبعد العيد؟ لا هو ما هوش العيدون ولا شيء. انتوا اليو بي بي مالكم دخل في اي شيء له علاقه ما بعد العيد، ما في. هذا الجنرال كورسز which you are not involved in اللي هي الانجليش والسلام والعرب والاخر. فانتوا as a UPP ان شاء الله your last day of exams will be the 8th or the 9th. I'm not sure. That's it. Yes, everything has to be before, yeah. طيب, okay. I assume that last time we finished the section 3 where we talked about the strength of acids and bases, and we agreed that we determine their strength based on the degree of ionization or degree of dissociation. So, and based on that, we said that all the acids, strong acids and bases will go to completion, while the weak acids and weak bases, they will be partially ionized. So that's the way we determine their strength. But for the strong acid, it is completely, it will go to completion. But the weak acid, they have an equilibrium. So we have an HA. Why this is not writing now. مش عم بكتب. طيب خلينا نشوف ليش. Just bear with me, okay? I need to see what's going on here with the pen. Okay, I'm just playing with the screen a little bit. I want to see if we can get the pen to work. Okay. Okay, I'm sorry. Every day they change something here, so to the point that we cannot do anything. The pen is not writing for some reason or another. Anyways, going without writing, which is going to be a little bit difficult, but there's nothing I can do almost at this time. All right, so regarding the strength of acids and bases, we said that last time that we talked about something called Ka and Kb. So the acid dissociation constant is known as Ka, and the base dissociation constant, which is known as Kb. Both of them can be determined if we have the initial concentration and if we have the hydronium ion, or if we have the pH. If we know the pH, then that will open, the road to determine the hydronium ion, because the pH is equal to the negative logarithm of the H plus. Or if we have the pH also, we can determine the hydroxide ion using the Kw, which we stated at the beginning. So for today, we're going to talk about neutralization reactions. That is already we stated that, but we're going to confirm it again, and that is the That is the a reaction between acids and bases. So when we react an acids and base, we call that a neutralization reaction. The objectives that we are supposed to cover for today is to define the products that are formed when we have an acid reacts with a base. And that is also something that we have talked about last time, and that is any acid with the base will always produce a salt and water. That is always the product. Now, we're going to use this concept of neutralization, which is a complete reaction between the acid and the bases to produce salt and water. That is going to be give us an equation where we can determine the concentrations of one of the acid or the base using a standard solution of the other one in a process known as titration. Now, titration is we're going to define it and we're going to see how we're going to use it. Of course, we're going to depend on concepts that is related or explained already in chapter 12, like how to find the number of moles of reactants and products and so on. Anyways, moving on with acids and bases, when we mix a solution of acid with a base, usually we produce a salt and water. As you can see here, that this is hydrochloric acid is mixed with sodium hydroxide. They will indeed react into completion by producing sodium chloride and producing water. So the sodium chloride here is not always, people sometimes they misunderstand the difference between the word salt. Salt is anything that has a ionic compound with positive and negative ions and positive and negative ions. But the word salt also we use it in our regular life for sodium chloride specifically, and that is the table salt. But in general, having an acid reacts with a base to produce salt and water, and that kind of reaction we call it a neutralization. Why it is called a neutralization? Because the product or the solution that we get when we finish is a neutral solution, especially when we have a strong acid with a strong base that they go into completion. Yani every part of the acid and every part of the base reacts, then the pH of the produced solution is a neutral. It's going to be a pH of 7. So for that reason, they call it neutralization reaction, because simply you are neutralizing an acid with a base, or the opposite, which is neutralizing a base with an acid. So that's what I was telling you about. The word salt doesn't mean always sodium chloride, but is an ionic compound consisting of an ion from the acid and a cation from the base. As you can see here, for example, the NaCl in this case, the cation, which is Na, is coming from the base, and the anion, which is the Cl minus, is coming from the acid. That's what the definition is about. Type reaction between acid and base will go into completion when whenever we have a strong acid with base. This means when they are completely neutralized, then the number of moles of H plus are equal to the number of moles of OH minus. I will take you back to the same example over here. So basically what is reacting between the acid and base is the hydrochloric acid is an H plus or a producer, and the sodium hydroxide is an hydroxide producer. So when they react into completely, then in that case, the number of moles of sodium hydroxide and the number of moles of H plus are equal. So that's what is stated over here, that whenever they go to completion, then equal number of moles or equal number of ions of both the OH minus and H plus are present in there with the equal amount. After you balance the equation, then you get a ratio between the two. Like, for example, here we have when we react hydrochloric acid with sodium hydroxide, since hydrochloric acid is a monoproduct, so it will react 1-to-1. So we have 1 mole of hydrochloric acid reacts with 1 mole of sodium hydroxide to produce the same thing, 1 mole of salt and 1 mole of water. But if we were to change the acid into sulfuric acid, and it is a diproduct, so it will produce two hydrogens. So for each 1 mole of sulfuric acid, you need 2 moles of sodium hydroxide. Why? Because we have 2 hydrogens that are ionizable to react with the hydroxide ion that is produced from the sodium. For that reason, you will see that we need 2 moles of sodium hydroxide with 1 mole of sulfuric acid. We can do the opposite, which is the base to become as 1 mole when we have calcium hydroxide. Calcium hydroxide in this case is having 2 hydroxide ions. So we need, in that case, 2 moles of hydrochloric acid to neutralize. But regardless, the ratio between acids and bases could be 1-to-1 whenever we have a monoprotic acid with with a base, or whenever we have a diprotic or multiprotic hydrochloric amine acid, it will need double the moles of sodium hydroxide, or the opposite in the case of that. So finding the moles needed to neutralization. Based on that, based on the fact that we can set up the ratio based on the number of ions of H plus and OH minus, then in that case, we can use that, which is already, we learned this from chapter 12. There's nothing new in here, but let's see. The only difference here is that we are focusing on neutralization reactions, which is the reaction of acids and bases. In the chapter 12, when we did calculate the number of moles, we're talking about a wide range of reactions, whether a single replacement, double replacement, combustion, whatever it is. But here we're focusing only on the neutralization reaction between acids and bases. So the question is, if we, react sulfuric acid with sodium hydroxide, according to the equation that is in front of you, the question is, how many moles of sulfuric acid are required to neutralize 0.5 moles of sodium hydroxide? So all what we need to do, as usual with this kind of calculation, that we use the given quantity and we create or we derive a conversion factor from the equation. What is the conversion factor that we are talking about here? What kind of conversion factors we have in this equation? Anybody from the Zoom? What kind of, or what are the conversion factors that we can derive from equation? طبعا انتوا ناسين الموضوع هذا, but that's fine. Read the equation. When you read the equation, it says 1 mole of sulfuric acid reacts with 2 moles of sodium hydroxide. So this is the conversion factor that we're talking about. Either 1 mole of sulfuric acid divided by 2 moles of sodium hydroxide, or 2 moles of sodium hydroxide divided by 1 mole of sulfuric acid, right? So these kind of conversion factors that can be extracted or derived from this equation. Which one we're going to use, depending on the given quantity that we have. The question is providing you with 0.5 moles of sodium hydroxide. So this means that your conversion factor, the one that you're going to use, should have the sodium hydroxide moles in the denominator. So it will be to solve the question, or to answer the question of how many moles of sulfuric acid are needed, you need to multiply the 0.5 moles of sodium hydroxide times 1 mole of sulfuric acid divided by 2 moles of sodium hydroxide. So this way, of course, we have to analyze, and that is, what we have, and the balanced equation says 1-to-2. This is the conversion factor that we talk about. So you multiply this by 1/2, and that is 1/4 mole of sulfuric acid is needed in order to neutralize a complete yes, thank you, Eileen, or Eileen, on the answer that you provided. Okay. All right. Why acid and base reaction called neutralization reactions? Because the produced solution is with a neutral pH. That's what it is. Solution has a neutral pH. Why? Because they are all consumed. يعني لا في H plus more ولا OH minus more. They all neutralize each other and they produce the salt. And that is only in the case of strong acid with a strong base. In section 4 or 5, the one which is the last one, which we will discuss on Thursday, is where we're going to discuss the pH of different solutions, depending on whether we have a strong acid and a strong base, or a weak acid with a strong base, or the opposite. That will produce different types of pH. But whenever we have a strong acid with a strong base, that is a complete neutralization, and it will produce a neutral pH. Right. Now, how we are going to use this concept in order to perform a titration, which is basically a procedure that is used to determine unknown concentrations using the concept of neutralization. So we need to find, what is the point in titration, how it is occur. So you can use the neutralization reaction to determine, as I said, unknown concentrations of either acid or base, as long as you know the concentration of the other one. So it's a process by which we add a measured amount of solution of known concentration into a solution with unknown concentration. Okay, till we reach the point where it is 100% neutralization. Yani, remember that when we have a neutralization, we have the number of ions, or the number of moles of H plus is equal to the number of moles of hydroxide, right? So when that happens, then we can determine, if we know one, we know the other one, they are equal, right? So once we determine the molar or the number of moles, with the help of the volume that we are using, we can determine the concentration, which is known as the molarity. Molarity is equal to the number of moles divided by that. So here's the procedure that we usually do in titration, which is a measured volume of an acid, for example, not necessarily an acid, could be a base, but an acid solution of unknown concentration is added to the flask. So we have a flask that we put in that, for example, we have a solution that somebody prepared and it says hydrochloric acid, but we don't know what is the concentration. All right. So we take a measured amount of that acid and we place it in a flask. Let's say we take 25 milliliters. We place it in a flask. Then we add several drops of an indicator. Why we need to add an indicator? What is an indicator to start with? Indicator is basically a material that will change color based on the solution, whether it's acidic or basic, right? So when we add the indicator, it will take the color of the solution we have, which is the acidic. Now, when we measured volume of a base of known concentration are mixed into the acid until the indicator just barely change the color. We start adding the base slowly till we reach a point where the color change. When the color change, this means that the solution is slightly become basic, which means that we finished all the acids. This is the picture of the titration. This is the flask, and the top one with the stopcock is called the burette. That is a long tube graduated, and you can fill it up with the one with the known concentration, regardless whether this is an acid or base, as long as you know the concentration. So here's the flask where we place the acid, for example, along with the indicator. So when we add the indicator, it is colorless. If we use phenolphthalein, for example, it does not have color whenever it is acidic. Now we start adding more base from the burette, and you will notice that once the drops are reaching the solution, it will change into this pink color. But if you swirl it, if you stir it, then it will disappear. Why? Because whatever base you added, it is now reacting with the acid. Okay, and will continue like that. Add and swirl till the color is persist, which means that we reach the point of equivalence, which is the number of moles of that is equal to the number of moles of the base. And just one drop more, that will take you to the basic solution. So we reach the point that the number of H plus is now equal to the number of OH minus. Okay, so then we do some calculation that we already know from chapter 12. The solution that is we have in the burette is called standard solution. Why it is standard? Because it is with known concentration. Anything that is with known concentration. So we have two solutions. One of them is acid and the other one is base. One of them is with known concentration and the other one is with unknown concentration. We react them with each other to the point where they are equal. How do we know that they are equal? With the help of the indicator. Okay, when we reach a point that is changing the color, then in that case you can use the numbers, which is number of moles with volume and number of moles with volume. The number of moles are equal. So using the volume that you start up with, you can determine the concentration. We will take an example and we'll explain, but before that, we have to explain that the basis for this is, again, in neutralization reaction, the number of moles of hydrogen ion is exactly equal to the number of moles of hydroxide ion. That is the basic thing. Now, that point where the number of moles are equal, we call it equivalence point. But there is something called endpoint. So what is the difference between an equivalence point and an endpoint? Equivalence point are where exactly the number of moles of H plus are equal to the number of moles of hydroxide ion. But the endpoint is the one where the color just turned on or changed. That is exactly 1 or 2 drops before after the equivalence point. So we keep adding till we reach a point where we reach the equivalence point. But we're not going to see that because the color is no color at that time because the number of moles are equal. We add 1 more drop, which is not going to affect our calculation though, to reach what is known as the endpoint, and that is where the color changes. So the endpoint is where the color changes and the equivalence point where exactly are equal. But for the simplicity of calculation, we will consider the numbers at the endpoint, not at the equivalence point. We cannot see it. Now, this graph here is showing you the titration. Remember that we started with what we have in the flask in our experiment here. We have an acid. So the pH is going to be low. And that's why we started with a pH of almost 1 before adding any sodium hydroxide. Now here's the sodium hydroxide. We start increasing that, adding more. As we add more, we're going to see the pH start increasing, but increasing very, very gradually. Why? Because the majority of the solution is still acidic. When we start getting very close to the equivalence point, you will see a sharp change in the pH. And that is because at that time, the number of moles of H plus left is very minimal and it is being consumed very quickly. So we reach a point here. Here's the equivalence point, which is at pH 7. We are talking about strong acid with a strong base. So their equivalence point will be at a neutral pH, and that is a pH 7. So as we adding this, the pH is increasing, as you can see. And then there will be a drastic change or a sharp change in the pH, and that is because the the hydrogen ion are being used up, almost finished. So we're going to see a sharp. Now, if we continue adding more base, of course, if we want to do calculation, you have to stop at this green point here. You stop and you calculate how many milliliters of sodium hydroxide we use, 50 milliliters. And how many liters we started with acid? We started with 25 milliliters. Do we know the concentration of sodium hydroxide? Yes, we know, but we don't know the acid. Now, there's a rule that you guys know, but I don't recommend using it, but just to remind you that you know that molarity, which is M, like the concentration here, times the volume is equal to the number of moles. Now we can say that M1V1 equal M2V2. It's not written in your book, and I don't recommend using it. Let's use the dimension analysis, which is always using convergent factor. So if we continue with the titration, it will go up here. At this point here, at the green point, what do we have in the solution? We have only sodium chloride and water. There's no H plus or OH minus. But if before that, we have the majority is H plus. After that, it is the majority is OH minus. But when we do the titration, as I said, we stop at the equivalence point. How do we know the equivalence point? By changing the color of the, here's an example. Now I wish that this start working again. Right. Let's read the question, and slowly we can solve it even without writing, which is we have 25 milliliter solution of sulfuric acid is neutralized يعني خلصنا. We did the neutral, the end point, the color has changed exactly when we used 18 milliliters. إذا بدك ترجع هون, what we used to get the equivalence point in the previous example, that was 50. In this case, we have only 18 milliliters of sulfuric acid were used up in that case. And we know the concentration of that. So if we want to calculate the number of moles of sodium hydroxide that is being used, we can multiply the volume in liter, not in milliliters, times the molarity. That will give you the number of moles of sodium hydroxide. If we know the number of moles of sodium hydroxide, we can use the ratio of 2:1 to find the moles of sulfuric acid. If we find the moles of sulfuric acid with the volume, which is 25 milliliters, then we can determine of the sulfuric acid. Okay, so that's what we do. We take the liters of sodium hydroxide. This is the one which is known. What is the liters of sodium hydroxide? It is 18 milliliters, يعني 0.18 liters. Then we change that into moles of sodium hydroxide. How we do that? By multiplying by the concentration, which is, if it is in this case 1 molar, this means that it is 1 mole per liter. So we multiply 0.18 liters that is being used times the concentration, which is 1 mole per liter. What is the meaning of 1.0 capital M or molar? When we say 1 molar, it means 1 mole per liter, right? So we use that, and once we have the moles of sodium hydroxide, we can use the equation to find the moles of sulfuric acid. Once we get this, we can change it into liters. Let me show you. Here's the liters of sodium hydroxide, 0.018. Why it is 0.018? Because we have to divide the 18 milliliters by 1,000 to change it into liters. It has to be in liters, because the molar or the 1 molar, it means 1 mole per 1 liter. So the liters goes with the liters, and we end up with 0.018 moles of sodium hydroxide have been used. Then we have to use the ratio, which is 1 mole of sulfuric acid per 2 moles of sodium hydroxide. Where that ratio is coming from? 1 mole of sulfuric acid divided by 2 moles of sodium hydroxide. Where we get this, ya Judy, from? The answer is simpler than this, is from this equation here. Yeah, you say from the equation, not from the number of. I'm asking you about the number. So the number came from the balanced chemical equation. That's the way the standard answer should be. Okay, so using this ratio, which is 1 mole of sulfuric acid divided by 2 moles of sodium hydroxide, then that will lead us to the number of moles of sulfuric acid that has been utilized in that flask. But we are not interested in the number of moles. We need to know the concentration. What is the concentration always? It is the moles by volume, divided by volume, but has to be in liters, not in milliliters. So all what we need to do is to divide this 0.009 by what? By 1,000. ايش 1,000? هنا جا 1,000. What is, let's read the question, yeah, Judy. We started with 25 milliliters. So that has to be converted into liters. Then we divide the 0.09009 by 0.025. So what we get in here, we divided moles of solution, solute divided by liters of solution, which is 0.009 moles by 0.25 liters. Now, where's the 0.025 coming from? From the 25 milliliters that we started with. Where is this coming from? From our calculation. So the concentration in molar will be 0.36 molar of H2SO4. So we were able to calculate the concentration of the unknown solution by using the concentration of the standard that we have over there. So in titrations, always we will provide you with either, in this case, we provide you with volume and unknown concentration, and a volume with known concentration. From the volume and the known concentration of the base, we can calculate the number of moles. Using the equation, we can determine the number of moles of the acid. Once we determine that, we divide it by the volume in liter, and that's it. We get the concentration. Okay? I thought there will be another example, but that's the only example we have for today. So basically, you know, this is the end of the section. It's a small section. I'm not planning to go another one because I know that you guys are under pressure with that. I will take the time that is left to fix the screen for the next section. معقد؟ وش المعقد فيه؟ وش المعقد فيه؟ لا، الموضوع سهل جدا. شوف. Listen to me. Listen. And I wish I can write this. I will show you. خلينا نعمل annotation and then we'll see. Annotate using the sheet drop. طيب. شوفي. انت in any titration, basically you have one solution that is with known concentration. هذا معروف الconcentration تبعه, which is 1 molar. All right? وهذا معروف الvolume تبعه, which is 25 milliliters. Then I start adding sodium hydroxide to it. When I reach the change in the color, the number of milliliters of sodium hydroxide that was used is equal to 18 milliliters. All right? So from these two things over here, which is the molarity and the volume, now the molarity M is equal to the moles divided by the volume, but it has to be in liter. Okay? مظبوط؟ طيب إذن the moles in that case, خلينا نحاول. Okay, so the moles in this case, from this equation, I'm just going to change it into the moles. Just solve for the moles. شو بتساوي؟ المولاريتي times the volume, صح؟ مظبوط؟ times the volume in liters has to be. طيب احنا عندنا المولاريتي تبعت الصوديوم هيدروكسيد ولا لا؟ Which is 1. So we have 1 molar times the 0.018 مش 18 لأنه الليتر has to be. صح؟ طبعا ال1 mole هاي هي عبارة عن 1 mole per liter. So the liter goes with liter, we end up with the number of moles of sodium hydroxide. Then from the volume and the molarity, we were able to determine the moles of sodium hydroxide. So from the equation, which is 2 to 1, so whatever we get here, half of it will be sulfuric acid, then 1 to 2, صح? Once we know the moles of this, طبعا احنا عندنا الفوليوم already معروف. We do the same thing for the sulfuric acid. Divide the moles by the volume, and that's the concentration. I mean, very simple. فكرة, by the way, the question might get complicated even more than this. هذا is very straightforward. But instead of asking you for the concentration, we could ask you for the volume. يعني نعطيك the concentration of both, and we'll miss one volume ونخلي the volume is unknown. يعني that's another way of doing the question. Okay, let's talk a little bit about the exam. since we're not going to see you till the classes on Tuesday are cancelled, the chemistry classes عشان نكون واضحين. So there will be no chemistry class, but we will be available in the office for your questions on Tuesday. The exam will be at 6 p.m. as usual in the auditorium, and it is covering chapter 12 and chapter 14 and 17. We are using ExamSoft as usual. We already put the exam together. It's going to be 22 questions, including 2 of them are bonus, as we did in the exam 1. And the time that is given to you is 60 minutes to solve that 22 questions. Okay? Extension show. Why we need to give an extension? Fish extension. We never done that. No. هذا موضوع محسوم. We already determined that. To compensate for any delay or anything, we give you 2 bonus questions. That's what we did. Okay, any questions or concerns about today's lecture or the exam, if you want to ask about the exam? No. Okay. All right. So inshallah, we'll see you next time in the auditorium where we have the exam.